Hello and welcome to the Spatial Structures Movers and Shakers interview series as we look ahead to the IASS Annual Symposium and Spatial Structures Conference organised by the University of Surrey and taking place virtually in August 2021. My name is Mark Richardson and today I'm joined by Mehdi Setareh, who is a Professor of Architecture at Virginia Tech. Mehdi is also the President of Setareh Structural Engineering and has been a consultant engineer since 1991. Mehdi's research interests include virtual environment, assisted structural analysis, and design vibration problems in building structures, as well as analysis and design of three-dimensional structures. Mehdi, thanks very much for taking the time to join us today.
Thank you.
It's a real pleasure to have you on the Movers and Shakers interview series, Mehdi. We always begin by asking our guests about lockdown. How has that been for you in the United States?
It wasn't that bad. Actually, we switched to online classes in March of 2020. And since then, we have been teaching classes online until this coming semester. Actually, in a couple of weeks, our next semester is going to start and all classes are going to be in person, even though the past few weeks we were told that, we need to wear masks when we go to classes. That situation can change also depending on what will happen, but I'm happy that we are going back to in-person classes because I think they are much more effective than just teaching classes online, and I'm more used to it also.
Yeah, good to hear we're moving back to some of the models that we were using pre-COVID there. And we also ask our guests about their career paths or career journeys. Perhaps you could give us an overview of your own career journey to date.
Yeah, I got my first degree in structural engineering in Iran, and then after that in 1984 I went to University of Surrey and I did my master's degree in structural engineering, and it was the first time I actually came across spatial structure. Professor Makovsky and Nushi were our professors, and I did some work on spatial structures at the time. And after that, in 1985, I moved to the US and went to University of Michigan and changed my line of research to vibration analysis and vibration serviceability of buildings. And that has been my main line of research since then, actually. A bit away from a spatial structure, but I have done spatial structure projects also, which I'm going to talk about it also today.
Thanks for that, Mehdi. We look forward to hearing about those projects shortly, and great to hear about your work with some of the big names of spatial structures there, like Professor Nushin. So thanks very much for sharing that. We were also interested to hear from our guests about a research paper or project that you are currently working on or have been working on recently linked to spatial structures.
In terms of general concept of a spatial structure, I think every structure is a spatial structure, you can call it, because every structure basically has a value. My line of research, as I said, mainly has been on vibration serviceability. We are working right now on some sort of innovative devices to control vibrations. We are working also on human structure interactions in terms of the dynamic action between humans and structures. We are working also on projects related to human gait and footfall forces, those kind of sort of research actually that I'm currently involved.
Great to hear it spanning some of the breadth of engineering there. So thanks for sharing that, Mehdi. Well, let's move on to the middle section of our interview, which is entitled Your Space, Your Structure. So at this point, I will hand over the presentation rights to Mehdi, who'll be presenting on a topic of personal interest to him. So without further ado, over to you, Mehdi.
Okay, now this project, which is called a Structure and Form Analysis System, is based on a research grant that we received from the National Science Foundation about 12 years ago, which was to develop a system, computer system, so that it helps architecture students to better understand the relationship between the structure and form. And I decided to use the medium of a spatial structure, and particularly double layer grids, for understanding this behavior. And the reason I did that is because the double layered grids are made of linear elements, and they are either in tension or compression, and it is much easier to visualize the behavior of a structure and how the changing form can redistribute the load and change the basically the forces that are in the structure. And we call this system, which is a web-assisted system and has got different modules, we call it a structure and form analysis system, or SAFAS, which is available to everyone. You know, you can basically go to our website, and which we are going to provide the link later. You can go to the website and also try SAFAS, learn about it, and also try to use the module that you can create your own structure. Then I'm going to basically explain this web-based system that we have developed here. Then this is the basically front page of the website. It has two modules. There is a module 1, which is called Knowledgebase, and it has different parts to it. It has 9 parts to it. Then we have got a module 2, which consists of a program which the user can use to create his own structure. Now, let's look at the knowledge base. It has got 9 parts. It has got an introduction, history, design, systems, advantages, disadvantages, assembly and erection, case studies, bibliography, and fundamentals. These are all related to spatial structures, obviously. And let's look at the history section here. It talks about the history of a spatial structure. There are 6 pages. Now here we have got Mero system, which shows how the assembly of Mero system is done.
This animation shows the assembly of a Mero system component. First, the cone is welded to the tube, and the bolt is placed inside the tube through the opening. Next, the sleeve is placed over the bolt and the pin is inserted. Finally, the bolt is tightened all the way into the node. This animation shows the assembly of the Mero system. Each member connects directly to a node, and the combination of all the nodes and all the members makes up the structure.
Now we can look at other parts of this module. Let's look at the fundamentals, and you can see there are different sections. We are looking at just the load section, and here you can see also more animation. There are plenty of animations in this module.
This animation shows the loads created by wind when passing over a gable-roofed structure.
There is no time for me to go over all of the section, but we can now go to another module, case studies. And these are the actual buildings that they have used spatial structures. And this shows how the spatial structures are actually, in reality, are assembled. Here you will see, actually, it was a roof for a gym, swimming pool actually in California. You see the columns were first set up. Then these are triadetic systems, spatial structures, and the modules are created. Then you can see the support pyramids that they are placed, and then the entire roof being hoisted and placed on the columns. And the first section and the second section, then that shows the assembly and also the erection. Then you have got the roofing, that is basically how easy it is to create a spatial structure. This is the module 2, which basically the program which we have developed. The user can make his own spatial structure, and right now you can use Windows 10. You know, this, or when we developed it was Windows XP. You can request an account, and there are frequently asked questions, and there are also tutorials. Then you can basically send us an email and request an account to use the the program. Once you have downloaded the program, then you can open it, and there are different configuration of the double layer grids. As you see, it is possible to basically change the depth and widths and loads, and you can also different types of support to be at the corner or the different type of background. Here we are using 11 modules on each direction. This is just an example. Then it creates its own structure and suggests some members. Then here we can show the loads acting on each node. There are different ways of showing it, also either color coding it or use a sort of glyph. Then you will get a username and a password from us, and you can use that to actually run the structural analysis. And the way it works is that you can name it also. Here I'm just calling it option 1. Otherwise, it's going to have just a timestamp. Then I called it option 1. Now it is running it. And what it does is that it sends the data from your computer to our server here and uses a SAP 2000 structural analysis program to analyze the structure and send it back to your computer so that you can visualize the force and you can see the force levels in the members, and it color codes it so that it will be easier for the student to see the effect of changing the configuration of the force. So you can see now here we are animating the movement of the spatial structure under loads. We can also show the magnitudes of forces different ways. There is a glyph 1, glyph 2. This glyph basically shows the forces in the member. Red color for compression and blue color is used for tension. The bigger the sizes are, the larger the force and the stresses in there. And then you can also highlight the maximum forces, the members that they have got maximum forces and the ones that they have minimum. Here you can see in the box on the top right corner the amount of force and stresses inside the member, both in tension and in compression. Again, tension is blue and compression is shown in red. Then one can now go back and morph the structure or change the shape of a structure. You know, our goal was to create a sort of free form here. Now you can do morphing automatically or manually. Here we are going to use manual morphing. You can either turn it into a dome or to a vault. For example, if you have got vault, you have got different way of morphing it. You can have either a smooth or linear or uniform, basically morphing it. And you can create your own shape, and you can have the axis around this set at X, Y, or Z, and you can apply to top and bottom layer or just the top layer or the bottom layer. Then the shape is, you know, can be changed based on the user preference. Here we are going to create some domes here. Then the user can just select the point, select the node, and pull it, and it can create the shape that the user wants based on the specification here for the dome, the radius of the dome, and you know, it can basically change the shape of a structure as they desire. And you can put also a roof here so that you can visualize it better. Then now it's showing the entire structure with the applied forces. And then we can run it again, basically do the same thing. This one, I'm calling it option 2 after I have changed the form. And then I can basically go and look at the changes in the level of forces that we get by changing the form. And as we change the form, we can see how the distribution of forces in the spatial structure is going to change. As you see, it doesn't take much time to process the data. Now we can basically have a split screen here and have our two options, option 1 and 2, look at the internal forces in these two examples that we have. Then you will see here that we can just go and color code the forces here. First, I'm going to display, you can see how the structure is moving under the load, and then we can also show the level of force. You can see for the regular one at the bottom, the maximum forces were at the center along the edges, but that doesn't happen when we have more fit. You can see the compression forces at the center along the edges is not as much as when you have got a uniform shape. Then basically we can use this system, and this is end of presentation, to basically create different forms and look at the effect of changing form on the level of force that we have got.
Mehdi, thanks very much for taking us through your structure and form analysis system there. That was a wonderful insight into some of the work you've been doing. Thank you very much for sharing it. We're now going to move to the final section of our interview, which looks towards the future of spatial structures, and in particular the 2021 conference and its theme of inspiring the next generation. What advice would you offer, Mehdi, to aspiring engineers or architects looking to enter the field of spatial structures?
Now, as I mentioned before, I think, any structure is a spatial structure, has a volume. But if you are looking at, a spatial structure in a traditional sense of it, what we studied under Professor Markowski and Nushin, is, geometries that they are made of linear systems, that they are interconnected. And they have got a lot of advantages, and they have also problems and disadvantages. They are very stiff system. They are very redundant. If you have got a local failure, you won't end up having a global failure. In terms of the material cost, you're going to have a lot of savings, and it can go very long span without much of internal support. These are the big advantages that you have got on a spatial structure, but there are also disadvantages. Disadvantages of it mainly first is the cost. Because it's very labor-intensive system, and where the labor cost is high, like in the US, then it is very difficult to justify their use because of the expense that it is related to it. The other problem that these spatial structures have is basically the creating new form and free forms, and again, because these are mainly traditionally made for a modular system, to create free form is challenging. And I think the new engineers, architects, they have to look at these challenges, how they can use technology to minimize and automate sort of the assembly and creation of these spatial structure, and how to develop systems that can be adaptable more to free forms. I have seen some examples of it, but still it is not very widespread. And I think those are the challenges that any new engineer that gets into the field of spatial structure will be facing.
Some really good insight there. Thanks for your thoughts, Mehdi. And what do you think are the most pressing challenges in the field of spatial structures with respect to some of our current global challenges, for example, environmental problems?
I mean, one big advantage, before we talk about challenges, the big advantage of also spatial structure is their sustainability. I mean, it is made of modular system. You can disassemble them and reuse them. That is the nice thing about the spatial structure. But I go back again to what I just mentioned before, because in terms of general environmental and health issue, I don't think there is much of difference between a spatial structure or traditional structure in a sense of the way we are defining it. But it goes back to those 2 points that I mentioned: the cost in terms of construction, and creating free forms, forms that, you can easily put together this system and get the form and shape that you want. Like I said, traditionally, this system have been used as modular system. And these are the 2 main challenges that I think is specifically related to a spatial structure from what I see.
That makes a lot of sense, Mehdi. Well, thank you very much for sharing your thoughts and ideas on that one. And indeed, thank you very much for taking us through your presentation today. It was really wonderful to see some of the fantastic work that you're involved in. A quick reminder to those watching the series: registration for the 2021 conference is still open. Please head to the conference website for full details and information in respect to that. And if you've enjoyed this video, or indeed any in the Movers and Shakers interview series, Please remember to like, share and comment. All of your views and thoughts are welcome. But Mehdi, once again, a pleasure to speak to you today. Thank you very much for your time. And as we get closer to the 2021 conference, hopefully we may speak to you again in respect of it. But for now, thank you very much.
Thank you.